Thanks, Kasam, for the introduction, and thanks everyone for joining us today. A little bit of introduction about myself. My name is Hussein. Originally, I'm from Egypt, and now I'm living in Australia. I have more than 15 years of experience in IT industry. I started off as a software engineer, and now I am focusing on the cloud architecture and integration architecture primarily. So we have started this series, interesting series that Kasam has kicked off last week, and all good. So we kicked off this series of cloud design patterns 2 weeks ago, and we had our first session to cover more of the messaging patterns. We talked about priority queue patterns and different sort of queues or messaging patterns, and it was a really interesting session. And for this session for today, we are going to talk about 4 key patterns. Static content hosting pattern, and you will see that the valet key pattern is very close and related and actually being used to secure the static content hosting pattern or implementation. Then we are going to be moving to federated identity pattern and gateway offloading pattern. These 2 patterns in the middle are primarily security patterns, and the other 2 patterns are kind of supporting the idea or going along with the same direction where those patterns are going. So we are going to have a pause after every pattern for opportunity for people to ask questions or anything they would like. And at the end, we are going to have a quiz or a question. As Kasam said, it's going to provide a free exam vouchers for the lucky 2 winners. So let's get started with our first pattern, static content hosting pattern. Static content hosting pattern comes under many categories of cloud design patterns. As you are going to see, it will contribute to change the design and implementation of your website architecture or any system you are putting in cloud, to be honest. Also, by doing this, it's going to contribute to the adding a lot of performance efficiency for your website as well. By splitting the dynamic content away from the static content, it's going to have a really positive effect of the performance of your website. And simply, the definition of this pattern is to try to deploy the static content in a cloud-based storage and try to deliver them directly to the client without having our web server to manage all of these traffic for this static content. And as I said, valet key pattern is very related to this pattern, and valet key is used to secure the static content hosting that we are going to put in the cloud-based storage. So let's dive into the example to help us understand this better. Let's assume that we have a web application and we have external users that are accessing our website. Let's say that our website has been hosted in Azure App Service. And of course, you might expect that the website will have dynamic content as well as static content. When we say static content, you could think of inline images, style sheets, or client-side JavaScripts, or even downloads, PDFs, or books. All of those things are required, or the client is required to access all of these static content every now and then in our website. Until that point, there is nothing wrong at all in our architecture. But we need to be careful of something, that our website is hosted in Azure App Service, and it's a compute service. And generally speaking, compute service is way more expensive than the storage service. So when we host both of our dynamic content and static content in Azure App Service, what's going to happen that the Azure App Service is going to split its computing power to try to serve both contents, dynamic content and static content. And then once we get more traffic or more users are using our website, then we will find ourselves need to increase our website tier to the higher tier, and then we are going to end up paying more money. In addition to, by making the Azure App Service serving the static content every now and then, it's going to degrade the overall performance of the web application, and definitely it's going to affect the performance of the dynamic content. Now let's see how we are going to use the static content hosting pattern to resolve this issue. And it's going to be as simple as having an Azure Cloud Storage, and in this case is going to be Azure Blob Storage. And then we are going to move the static content from our web application, from our Azure App Service, and put it in Azure Blob Storage instead. So what's going to happen when the client is accessing our service or our system or our website, the website is going to respond back with the location for these blob storage, so the client can download, or the browser can download, all of these static content from the blob storage directly. So what we have done, we have offloaded our Azure App Service. We have offloaded the static content from our Azure App Service and put it in the blob storage and allow the client to access it directly. So now our Azure Web Service, Azure App Service, is going to serve the dynamic content for the client requests only, which is going to have a tremendous improvement for the performance of our website in general. That's in brief what this pattern is about. Now let's take it one step further. And let's assume that our website is hosted in Azure App Service, hosted in Australia region, and the blob storage as well is hosted in Australia region as well. It will be perfect if the client is connecting to our website or connecting to the blob storage from Australia as well, because it will not be any cross-region traffic in this case. But what if the client is hosted in another region, let's say in Brazil? In this case, the client will have to do a lot of cross-region traffic in order to reach our website and also to reach the static content in our blob storage, which is going to have or provide a little bit of latency for the client in this case. And what we can do in this situation is to introduce a CDN, Content Delivery Network. And what the Content Delivery Network is doing is to try to replicate the static content in our blob storage into all edge locations in Azure around the globe. So in this case, the client is going to be pulling the static content from the CDN instead from the blob storage in Australia. So in this case, the CDN is going to grab this information from the closest edge location to the client. Probably it could be something in Latin America. And then we need to specify the origin of the CDN to be our blob storage that hosts the static content. All of these distribution of the static content that the CDN is doing is happening behind the scene. And actually, we cannot control which edge locations we want to host our static content into it. As soon as we specify this blob storage as the origin of the CDN is go by itself and deploy all of these static content in different edge locations around the globe. So this is how we can use CDN along with the static content hosting pattern to make our website available for users around the globe. Now let's take it one step further. There is a feature available in blob storage that allows you to host a static website by using Azure Blob Storage only. Like you don't have even to use Azure App Service and put all of your static website content in the blob storage and make the client able to access it directly. And in case you wanted to do some processing, you can have an Azure function or even app service that's going to grab information from a database or perform some processing that you might require. So in this case, you have hosted your static website with a really cheap price. Because as we said before, the storage service cost is very low comparing to the compute service cost. So that's briefly what this pattern is about. Now let's talk about some considerations you need to be aware of when you use this pattern. First of all, you need to see and to make sure that your cloud storage supports both traffic, HTTP and HTTPS, because sometimes you want to make sure that the clients are going to access the cloud storage in a secure way. And we are going to see this in more details in the Valley Key pattern. And as we said before, you can use a content delivery network or CDN to improve the performance of grabbing the data from your blob storage or any cloud-based storage. And the storage accounts are geo-replicated, so IP address could be changing. So you have to use the endpoint or the URL of your blob storage to make sure it's going to stay the same at all times. As we said, it's challenging to have some static content in a storage account and some static content in a compute service. If you are going to use this pattern, it's going to be best to hand over or offload all of the static content in your website and put it in blob storage. If you are going to split it, some in the Azure App Service and some of the in blob storage, you might get confused where is where, and you might get lost if you want to troubleshoot certain error. So it's best to follow a certain approach or a certain direction. Also, the storage service must allow public read access. And it's important to disable the public write access because we want to allow everybody to be able to see our website, especially if we are hosting JavaScript files or any public files, public static files that are going to be used to loading our pages. However, if you are going to have some secured resources, you want to secure them using the value key pattern, which we are going to talk about them later. But definitely you are going to allow public write access if you are hosting a website or having a service like YouTube, for example. Because YouTube, if you are a course creator, you will need to write some content to this blob storage. So bottom line is you need to be very aware of what permissions you are providing to different users and provide them with the least privileges required. As I said before, using the value key pattern to control access to certain resources in blob storage. May I ask you guys just to put your mic on mute because we are hearing a lot of background noise. Yep, thank you. Yep, let's move on. And then now let's see when we are going to use this pattern. If you want to minimize the hosting cost of your website compute service, because by offloading the static content to a blob storage, you will see that you can run your website in a much lower tier and achieve the same performance outcome that you are expecting as well. Also, when you want to expose static content for applications running on-prem, you might have a website or an application running on-prem, but you want to allow the clients or offload the static content to be hosted somewhere else so you can leverage this pattern and improve your application that's running on-prem. Also, use this pattern when you want to locate content in more than one geographical area, especially if you are going to use a CDN. It's going to be perfect in this situation as well. Also, when you want to monitor cost and bandwidth usage of your website, it's going to be good to split the dynamic content from static content so you can apply the monitoring separately on both of them. Now let's see when you shouldn't use this pattern. When you need to apply or perform some processing on the static content before you are going to deliver it to the client. Because as we said, the client is going to interact or connect to the blob storage directly and grab the files or information they want to grab. If you are planning to do any transformation or any processing, it won't be useful in this case. Also, you need to be aware of that the volume of the static content is very small. Like if your website is really simple, don't bother and implement this pattern. Yes, Azure Cloud Design Patterns is really best practice to implement in cloud environment, but at all times we need to make sure that we follow KISS principle. Keep it simple, stupid. If your website is really simple, really small, don't bother and implement this pattern. Just to keep it in Azure App Service in a really low tier, as long as it doesn't get too much requests or too many hits from different users. So that was in brief the static content hosting pattern. We are going to pause for a few minutes and take any questions if anyone has any question about this pattern. Yep, go ahead. Feel free to put it in the chat window or unmute your mic and just ask the question.
What is Azure Tenant?
Azure Tenant?
Yes.
Yeah, Azure Tenant, it's something that's used when you create your subscription. If you are the global admin of the subscription, you create a tenant or separate tenant for each Active Directory. So for example, you might have your Active Directory in a tenant, and when you create a B2C to be the validation or authentication for different clients who are going to authenticate with your organization or your different applications, Microsoft doing it in a way that you are going to use this B2C in a separate tenant away from the original tenant that you have created before. So I'm going to go through the questions been in the chat window quickly. Can we put PHP file in the blob storage? Yes, we can. And someone answered it. Great. Yep, great. Can we access the blob storage similar to like normal DB? If so, row level data access is possible. Matan, can you elaborate a little bit on this question, please? Okay, so if I understand the question correctly, yes, we can access the blob storage similar to normal DB or normal to any resource actually. If you are going to create a blob storage and make it publicly accessible, anyone around the world can access this blob storage and see its content. And if you are going to put some files that are rendering or running into your website, your website is going to use this blob storage for rendering these files as well. CDN can only process static files, as it can only cache the HTML and media responses. CDN in general takes on origin. The origin, for example, one of the origins is that the CDN can take is the blob storage, and whatever information you are going to put in the blob storage, it's going to be replicated using CDN. It's static files, and as we said, this pattern is about static content hosting. So we are moving static files for our website into the blob storage, and then we put the CDN to make it accessible for everyone around the globe.
Hi. About the content management system, right? Where do you put the content? In content management system, I have a lot of content which is like kind of static content, but somewhere you need to process that maybe like in database or app service or storage. So where would you prefer it to place that HTML content in a CMS application?
Yep. So the CDN is a global service. So wherever you are going to make the origin of the CDN your blob storage, it's going to refer and replicate all of these content in multiple edge locations around the world. Does this answer your question?
Yes, I'm trying to understand, like in CMS application, right? You have a lot of HTMLs, but somewhere you need to process it. So, that processing is like a very routine process. The same processing will be processed on the page 1. The same processing will be processed for the say page 2 and page 3 and all those things, right? So the processing is for same for all the content, most of the content.
Okay.
But that content is a static content that is not going to change, right?
Yeah.
So whether it is prepared it to be on a storage or app service or in a database.
That's a good question. If you remember in the anti-patterns, when we said when you shouldn't use this pattern, if you want to do some processing on the website or in the content before you deliver them to the client, you cannot use this pattern, because by using this pattern, you allow the clients to directly grab these files from the blob storage directly. So in your situation, I don't think it will be valid, as we've already mentioned before. Does this answer your question?
Right. Yeah. Adding it to your answer, like what, because content is a lot, and so what will happen, like, or is it a good approach to like process that content? What are the processing are going to do it? Just process it in the app service and then move that content to the storage account or the CDN, and that becomes static content.
The main driver here is the business requirements. And we are trying to adapt our solution to meet the business requirements. So definitely you are trying to do some processing on the static content before you deliver them to the client for some reasons that the business has highlighted. So ideally, we want to follow the business requirements and make sure that the business stakeholders are happy with our implementation. So if there is a way for you to process these files on the background, and then you put the files on the blob storage to allow the clients to access them directly. If this will work for you, then perfect. Go ahead and implement that. But I'm not sure if that will work for your situation or not.
Okay, got it. Thanks.
All right.
Thank you so much.
Thank you. In a real project, can you share any example of blob storage? Yes, exactly. As we said, so when we offload the static content and put it in a blob storage to allow this separation between dynamic content and static content. This is the best use case of this pattern. However, you can use the blob storage for other scenarios, like if you are going to upload documents from the clients or receive documents from the clients or receive videos or different bunch of things, you can use a blob storage to host or store all of this information instead of just storing them somewhere else. So thanks everybody for your questions. Let's keep moving to make sure that we are going to be finishing on time. Now, moving to the valet key pattern. Valet key pattern comes under security and data management, and the main purpose of this pattern is the security of our resources in a blob storage, as we are going to see. And we are going to secure it by using a token. So the client we are going to provide, so we are going to provide the client with a restricted access to get some resources in our blob storage. And the main purpose of this is we are going to offload the data transfer of our application. As we said before, we want to offload some of this traffic from the main website that's hosted in Azure App Service and direct it somewhere else so the clients can go ahead and do it on their own. Unrelated patterns to the valet key pattern, gatekeeper pattern, and static content hosting pattern that we have just talked about. Now let's first understand from where the name valet key comes from. So the valet service, probably everyone is aware of it. When you go to a hotel or casino, these are the service that you hand over your car key to them, and then they take your car and park it in the parking lot, and then bring your car to you when you finish whatever you're doing. But in this case, the car owner would need to provide his car keys to the valet, of course, so to be able to drive it. But the problem here is this car provides unrestricted access to the car. And actually, the valet doesn't need to have all of these access, doesn't need to access the CD player or the car boot or drive the car miles away from the location he picked it up. So all of these concerns make the car vendors to think of or inventing the valet key, which is another key that the car owner can give away or hand over to the valet person, so the valet person can have access to the car to drive it to the parking lot and bring it back. At the same time, it's going to be a restricted access. It won't allow them to drive miles away from the location they used the key. It won't allow them to open the car boot or see the player or car roof or whatever other features. So this is a bit of context of the valet key, and this is what we are going to use exactly in our situation. So we are going to provide our client with a certain token to allow them to have a restricted access to certain files that are hosted in a blob storage that we have already put in a static content hosting implementation that we have just talked about. Now let's dive into the example to help us understand it better. Let's assume that we have a group of users that are using our website that's hosted in Azure App Service. And then we have a cloud storage that hosts many files, many static files, video files, audio, books, PDF, or etc. And what's happening in this case is that our website is managing the traffic or responsible for the data movement from the cloud storage to the user to grab all of these files from the different cloud storage locations and do any transformation required and deliver them to the user or even stream them to the user. Also the other way around, the website might accept some uploads from the client and then to put it in the cloud storage. So this is exactly the same challenge you have talked about before. The website is performing a lot of compute resources or hosting a lot of compute resources for these data movement operations between the cloud storage and the client. And it will be even better if we could allow the client to directly get this content from the cloud storage, whether you want to download it or stream it or even upload it. And by doing so, we will free a lot of resources for our website and make it to perform better and quicker and more efficient. But the main challenge here, how we are going to allow a secure access from the clients to the cloud storage where we hosted our files. And the second question, how our website will be aware of the clients accessing the data in the cloud storage. Because we want our website responsible or able to block access for any user at any single point of time. So how are we going to make this available? And this is exactly the challenge that the valet key pattern is trying to solve. And what we are going to do is but just before we get into solution, we all already know that the cloud storage or blob storage doesn't allow authentication to different users. Like we cannot send the username and password to blob storage and the username and the blob storage will authenticate this user. Same for authorization. It's not possible on cloud storage or on blob storage. But what's possible is to get a token to validate this token and make sure that the client has access to certain resources for a certain amount of time. And this token is going to be generated from our website, passed back to the user, and the user is going to use this token to access our files in the cloud storage. So let's have a look at this diagram, which is going to explain it better. So the first step is the client is going to request access to a certain resource from our application. Then our application is going to validate the client, authenticate it, and make sure that the user has right access to these resources. And then our application is going to generate a key or token and send it back to the user. Then the user is going to use this token to access the resources in the blob storage. And by doing so, we have offloaded this kind of traffic. Instead of was going to our application in the past, now the user is offloaded or redirected to get this data from the blob storage directly. So this is exactly what this pattern is about. And one important point that we need to be careful about here is we want to make sure that this key or token has a short time validity. Like for example, if the user is expected to download 10 mega files, you don't want to allow this token to be valid for 24 hours. Sorry guys, can you put your mic on mute, please? Yep, thank you. So you want to make sure that the token is valid for the time that's enough for the user to download or to do the action they want to do, because the key might get compromised or stolen by an attacker, and they might do some invalid operations on our data, which we are going to cover it in more details in the considerations. Now, very first thing in the considerations, you need to manage the validity status and period of the key. Because as we said, the key might get stolen or compromised. And if this is the case, you want to make sure that you reduce the attack surface. If the action the client is going to perform is going to be performed in 1 minute, don't provide them with a valid key for 24 hours. In case an attacker is stolen the key, they can do a lot of damage to your content in these 24 hours. So make it as short as possible. At the same time, make it short enough to allow the users to perform the actions they are trying to do. Because if it's very short, the valid users might not get any chance to perform these operations at all. So you need to have a good balance between both. Also, you need to control the level of access the key will provide. If the user is expected to do some read operations, just restrict the key for read operations. If the user is expected to upload some videos to YouTube or something, restrict the user to just have a write-only access. You don't want to provide them with unrestricted access to your blob storage or to your cloud storage. Also consider how you are going to control users' behavior, and it's very difficult and challenging, to be honest. So user behavior in here, we mean if a user has a valid token, how you can be sure that the user will not download a certain file multiple times? Or when they have a valid token to upload a certain file, how can you be sure that the user will not upload the same file multiple times to the blob storage? It's not about the performance or efficiency. The blob storage can take all of this load or all of this data, but the problem we have in here is the cost. You might run into high operational cost because of these, a lot of data movement or data transfers that a certain user, because of this unusual behavior, is performing on your blob storage. You can't control it. There are some ways you can control it, and we are going to get into it probably down in this list. Yeah. So you need to validate and sanitize all uploaded data. Yes, because the client is a valid client, they might uploaded malicious data to your blob storage. Or even though an attacker might have compromised your key or stole your key, and they might upload some harmful data in your cloud storage. So before processing any data that's been uploaded from clients, you need to validate them. And definitely you need to audit all of these operations, client accessing your cloud storage or downloads or upload certain files to allow you to troubleshoot any issues that might happen. And you need to make sure that you are going to deliver the key securely. When you send the key back to the client, you want to make sure it's been delivered through secure traffic, HTTPS, not HTTP, to make the life harder for the attacker to compromise this key. Also, when you want to protect your sensitive data in transit, We already know that data, as a rule of thumb for data security, is data must be secured at rest and in transient. And in blob storage, if we have configured it properly, then we are assured that our data is secured at rest. And we want to make sure in here that the data is secured in transient as well, by having or enforcing the client to use SSL certificate while they are downloading our data from the blob storage. So I'm going to get back to this point, how we can control the client behavior. If you are going to make the validity status or validity period of your key very short, it's going to restrict the client to have a certain number of operations to perform using this key. Also, what you can do is once the client performs an operation, for example, a client has uploaded or downloaded a certain file or document, what you can do is that you can invalidate the key from your application. Then the client will have no chance to perform multiple operations using the same key. Also, you want to think of a situation when to provide the client with an opportunity to renew the key before it's been expired if they are in the middle of a certain operation. So these are the different considerations you need to be aware of when you use this pattern. Now, when we should use this pattern? If you want to minimize resource loading or maximize the performance and scalability, again, this is primarily comes from the static content hosting pattern because we are offloading the static content somewhere else, which is highly available, and it's going to be more available and easier for the client. Also, when you want to optimize the operational cost, because by doing this, we will find ourselves are able to run our website in a much lower tier than having it hosting everything. Also, when the client regularly upload or download data, we want to direct them to the blob storage, because if we directed all of these uploads or downloads to our website, it's going to be very disturbing and it will take a lot of computing resources from our website, which is going to affect its performance at the end. As we just said, when the application has a limited compute resource available, you don't want to overload it with managing a data movement between a cloud storage or a client. Also, when the data is stored in a remote data store or in a different data center, you want to make sure that the clients are able to access the data in a blob storage in a secure way. Now let's see when you shouldn't use this pattern. If the application must perform tasks or some processing on the data before it's been stored on the client, because the main thing about this pattern is the client is accessing the data directly on the blob storage. If you are expecting to perform some processing on these data, it won't work for you. Also, some applications are designed like all the styled application cannot work well with this pattern. So if this is the case with your corporate application, don't try to enforce it because it can be hard or very hard to use this pattern with certain applications. Very, very important to have audit trails or control the number of times the user, number of times the data transfer operation has executed. So we said already before that it's very important to keep audit trail of different actions or operations happened on the blob storage. But this point is about if it's important for you to audit how many times a certain user downloaded a certain item, it won't be possible because the audit that we have talked about before, just to audit the operation, like someone has been able to download or upload the data, it doesn't audit the number of times because a user might have a token that's valid for 1 hour and they might uploaded the same file 100 times. You cannot see this level of details in the auditing that we have talked about before. And if this is a business requirement, then you shouldn't use this pattern. Finally, if it's necessary to limit the size of the data, if you want to restrict the client to not to upload files more than 5 megs or something, you cannot use this pattern. What you can do instead is to provide an application layer to perform the size validation. And if the size is correct, then you are going to allow the clients to move forward with the next step. So that's it for the Valley key pattern. I hope it was clear and interesting, and we are going to pause for a few minutes for anyone if they have any question. I saw one question already on the chat window. Validation of the data before upload can degrade performance. So how can we handle? So this is the thing, the data cannot be one of the things, validation of the data. Yes, in this case, you need to hand it over in your website so you can validate simple items like, for example, the size of the files that you are uploading. And then if everything is valid, then you are going to hand it over to the blob storage to do it. However, if it's a heavy validations, probably you might need to think of it. Are those validations could happen at the front end side, or you can split them at the front end, at the back end. But generally speaking, it's yes, running some validations or having some validations in between, it's going to degrade the performance. But our target is to make this degrade of the performance as little as possible. We can use Azure function as trigger. Okay, not sure if it's a question or just an information, but thanks for that. Is token generation can be done only at the application end, or Azure has a token generation authentication features to plug in and play? So you can generate, at the end of the day, you want to make sure that your application in control of this access at all times, right? So because, as I said, at some points or in some scenarios, you want your application to invalidate the key to stop a user from accessing this token or using this token anymore. So you might be able to leverage some Azure resources to generate the token for you, but you need to keep your application in charge of this token process, because if you decided to invalidate all of the tokens because maybe you are under attack or some user misbehaved or uploading many documents, you need to be in charge and be able to stop all of these at once. For validation. Yes, we can use Azure function as trigger for validation. Yep, absolutely. Are these keys SAS token? Yes, they are. Absolutely, they are. All right, so let's move on to the next pattern. And this pattern is talking about federated identity pattern. And it comes under primarily security category of cloud design patterns. And it's about delegating the authentication of your application to an external identity provider. And in our case, it would be Azure Active Directory or Azure Active Directory B2C, business to consumer. So let's get to the example to help us understand it. So let's assume that we have a group of users that are in your organization, like your employees, for example. And your employees more likely will have to access internal applications that you have developed in-house, as well as external applications. So, for example, you might have more than one internal application and more than one external application. And what's going to happen that the users will be required to access all of these applications to perform different tasks. But the thing here is that the user will have to keep in mind or maintain different username and password for each of these applications internally and externally, which is going to be a nightmare for your employees in the organization. It will be even better if you can allow the employees to log into all of these applications using just one username and password, which is their corporate username and password. But now, how are we going to implement this? But in addition to this, also, before we get into the solution, you will have to spend the time and effort to implement an authentication module for all of your internal application. And anything you are implementing, you will be responsible to maintain it and fix its issues in future, which is going to take a little bit of operational time and maintenance from your team. So if this is not the best way to implement it, what should we do? So what we are going to do in this case is to use Azure Active Directory, as I said, and then we are going to direct the users to authenticate with Azure Active Directory. And then once they are authenticated, they are be allowed to access all of these applications, whether they are internal applications and external applications. And also there is a security lens you need to keep in mind here. If an employee left the organization, and in some big enterprises, they might have hundreds of different applications, internal and external. If you don't have the single source of truth for the user identity, then it's going to be a nightmare for the application admins to run through all of these different apps and try to disable the user access to all of these apps. Internal applications might be a little bit more secure because they might be behind the firewall, but what if what about the external applications that are accessible over public internet? And if you might forget to disable the employee access to one of these applications, they can still using this application even though they have left the organization. So the best practice we are trying to do in here is to have a turnkey solution. When the employee leaves the organization, we just disable their account and they lose access to all of these applications at once, internal and external. So now let's look at this diagram to help us understand it better. So the first step here, we need to build a trust between our service or our application with the IDAP, identity provider, in this case, Azure Active Directory. So this is one of exercise that we do when we try to authenticate or building a trust relationship between an application and the Active Directory. And then once we built this relationship, the client or the customer can directly authenticate with the Azure Active Directory. And if they provided the right username and password, Azure Active Directory is going to respond back with the STS token, which is the client is going to use this token to be able to access our application or our services. So this is exactly how we can implement the federated identity pattern. And also, more importantly, it offloads the implementation effort on your team to implement an authentication module that takes care of this implementation. And very similar to it, and we are going to get into it in few minutes, the gateway offloading. So probably I'm gonna skip this slide for now till we get to the gateway offloading. Now, let's talk about the considerations you need to be aware of when you use the federated identity pattern. It's a single point of failure for your application. And if you are already aware, Azure Active Directory has 2 incidents this year that affected the availability of Azure Active Directory globally. If you are going to use this pattern, you need to be aware of this. You might be already aware of it, but your business stakeholders need to know it, and you need to put them very clear in front of their eyes in case of they come in future to blame you, like the availability of Active Directory wasn't available. Everything has pros and cons, and it's more about clarity and transparency. And you just provide the business stakeholders with the pros and cons of using this architecture or implementing this pattern. Also, this pattern provides you with a role-based access control, which can provide you with you can restrict or have different permissions, pretty much similar to what Azure has, different roles like contributor, reader, owner, administrator, and then you can provide different access based on the role. And this is called the claim-based authentication. Like what we have talked about is called the claim-based. You might have a full control to provide what different attributes you can provide back after the user has been authenticated, but you have less control on the external identity providers, which they are going to provide you only with an email address and the customer name, and you need to be prepared for that. Also, you might have a situation that you have trusted more than one identity provider. And in this case, you want to make sure which identity provider is going to be used for direct or redirect for the authentication for your clients. Now let's see when you should use this pattern. If you want to implement a single sign-on in your organization, or if you want to have a turnkey solution to block access to a certain employee at any point of time. Also, when you have a federated identity with multiple partners or multiple businesses, you want to allow them to have an access to your organization or your cloud environment without actually creating user accounts for them in your Active Directory. And also having a federated identity in a SaaS applications, which is all of these SaaS applications are now trying to do, to have different authentications with Facebook, Google, YouTube, Yahoo, Microsoft, etc. When you shouldn't use this pattern, when all the users of the application can be authenticated by one identity provider. Also, if the application cannot handle claim-based authentication technologies, you cannot use this pattern in this case. So I'm going to jump straight into the gateway offloading pattern, and then we are going to take questions at the end because we have probably 30 minutes left. So the gateway offloading pattern comes under design and implementation and operational excellence, and it's all about offloading certain services from your application to Azure services. And we have already seen one of these styles by offloading the static content to a blob storage, or offloading the authentication to Azure Active Directory, but there are more services or more modules you can offload from your application. And the more you can offload, the better for your application, of course. Related patterns for this one is backends for front-end pattern, gateway aggregation, and gateway routing pattern. Now let's assume that we have two services in our organization, and the clients are using those services. These services will have to implement the front modules like token validation for security, encryption for securing the keys, and then having to manage SSL certificates in addition to authentication and authorization, as well as logging and monitoring and throttling limits to make sure that not a certain user will penetrate through our service. And guess what? We will have to implement all of these modules across all services we have in our system or in our organization, which is going to be a lot of effort that we will have to do. So what is our solutions or what are our options that we can use? And we have already touched on some of them already. So instead of the clients or instead of having all of these modules implemented in one service, what we are going to do is to leverage to the existing Azure services like Azure Load Balancer, for example. And we are going to make our load balancer to do the SSL offloading for our certificate. So the client is going to have an encrypted traffic from the public internet to the load balancer. And then we are going to perform the SSL offloading at the load balancer and continue unencrypted traffic between our system or through our services. And by doing so, we will find that we can offload SSL certificate module from our service. And the second one we have just talked about is by using Azure Active Directory, we can offload multiple modules like authentication, authorization, or token validation, and then we can perform all of these functions at the Azure Active Directory level. And similarly, we can use Application Insight as well to perform a lot of monitoring to our service, to perform performance checks or failures about our service and have a lot of metrics or alerts for our service. And similarly, the log analytics workspace. If we're using it properly, we can offload the logging from our service and make it to log analytics workspace. And similarly, we can use Azure Key Vault as well. If we're used it to store our secrets, we can offload the encryption management from our service and put it in Azure Key Vault instead. And for the throttling limit, we can use an API management, for example, to put some throttling limit on the APIs, and then we can offload the throttling limit from our service. And if you are using a functions app, you can specify throttling limit on the functions app directly as well. Also, the API management can perform some other functions like perform a token validation, GWT token validation. You can use it in the inbound policies of your API management, in addition to the SSL certification offloading as well. So after you have offloaded all of these modules, you can then use them across all services in your system, which is going to make your implementation much easier and more streamlined or more consistent with different services in your system. So this is what the gateway offloading pattern is about. It's stretching a little bit after the federated identity that primarily focused on the Azure Active Directory. However, the limit is not only focused on those services only. This is just to give you an example or idea what are the different services we can offload from our service. And the more you can offload, the better for you and for your system. Now let's talk about some considerations you need to be aware of when you use this pattern. You want to make sure that the service you are going to offload to, it's highly available. As we mentioned before, Azure Active Directory had 2 incidents this year, and it could happen to all of these other offloaded services. So you want to make sure that the service is highly available and it's well communicated with your stakeholders as well. As well as the service is highly available, it has to be scalable enough to be able to take too many requests from different clients. Also, you need to offload the features that are used by the entire application. Like if it's you don't want to consume or start making your application use an Azure service for just one line of code or one feature only. I can't give you an example on this, but You don't want to add more constraints or more boxes into your architecture for just a very small or tiny area or function in your system. Also, you should never, ever upload or offload the business logic. Your business logic has to stay in your application at all time. The gateway offloading pattern is not a place to put the business logic for your application. Also, you need to keep the correlation IDs to keep track between different transactions that are happening on your application. Now, when you should use this pattern, if you have a shared application deployment features like SSL, logging, throttling, all of the things that we have talked about, if you have a common feature across application deployments that may have different resource requirements. Also, when you want to move the responsibility to another team. Very good example by offloading the authentication to Azure Active Directory. Now your developers or your team doesn't need to worry about the authentication module anymore. You hand it over to the network team or sysadmin, which they manage the Azure Active Directory. However, Microsoft itself makes sure that Azure Active Directory is up and running and highly available. So that's it for all of the patterns for today. So we're gonna have a few minutes for questions before probably I can put the quiz that we have mentioned